Hello everyone, welcome back to my channel. So today we are going to discuss another problem, but before going forward, if you've not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. Problem is remove duplicate letters. We are given a string and we need to remove the duplicate letters so that every letter appear only once. You make sure that your result is the smallest in the lexicographical order. Lexicographical order means when we have ascending order. So like this is a string, so if there are all permutations of the string and those are arranged in the ascending order, so our string, whatever string we will make, that should be in the like the smallest in the lexicographical order, meaning it should be the smallest among all possible results. Okay, so let's see how we can approach this problem. Here, see this test case BCABC. So here what we are doing is we are taking A first, then we are taking B, and then we are taking C. We are not taking this B. Why? Because here there is A. So we are taking this A, and we are not taking taking this A, and we are taking this B. We are not taking this B. So let's take this test case and just let's see how we can approach the problem. So we have B, C, A, B, C. Fine. Now see, over here, we have B here, but B also we have here. Here we have C, but C we have here also. So either we can take this B. Fine, we take this B, then we go to this C, then we go to this A. This string we can make. Or what we can do is we do not take this B, we take this B. So we can have A, this B, and then this C. Another thing which we can do is we can take this C, this A, and this B. C, A, B. Fine, A, B, C, C, A, B. So from these, like lexicographical, like the smallest one, which will come when we do ascending order. So this is the lexicographical smallest, A, B, C. The smallest number, and then it's increasing. This here first letter is C. Here first letter is B. But this is obviously smaller, right? First letter is A. So the thing is that we will prefer, see, the thing is we will prefer taking the smaller letter. Smaller letter when I say, meaning A is A smaller than B. Fine. Prefer taking smaller letter. So see, over here we have taken A first and then we have taken B. Let me just change this test case to something different. So let me do one thing. Let me have something like this. C, A, B, C. So something like this. So or let me do it like this. B. B will be coming here or before this. So like this. It's C, B, A, C. Now the thing is, guys, we have to see C. We can take this one also. So there is no problem for C. But B we have to take this only because there is no B after this. Fine. In the previous test case was BC, ABC. In that we neglected this B. This B we did not take. Why? Because B was here after A. But here B is only this. Only there is one occurrence of B. Only there is one occurrence of B. So B we will take this one only. So B, A, and then C will be the output for this. One could be C. We take this C. We do not take this C. We take this C. C, B, A. But obviously this one is smaller. So that's why we are taking this. So the thing is we will be prefer taking smaller letter. But if like this B has only, like there is no other B after this. So we'll be taking this B only. Fine. So we need to store, but we have to store the, see, if we have to store the last index. We have to store the last index of a letter, of a letter. Because see, over here we neglected this b. We neglected this b because we knew that b is here. So there could be multiple b's, right? B could be here also. So something like this could be there. B, C, B, A, B, C. So we will neglect this b. We will neglect this b because we know that b could be here also. B is like the maximum index where b is. So 0, 1, 2, 3, 4, 5. So maximum index here is b. Fine. So we have to store the last index of a letter so that we can check, can we neglect this b? Can we neglect this b? Because we can neglect because there is another b present here. So if we are at 2 index, we can neglect this b because this b is also present at 4 index. Fine. So we will get it afterwards also. But let's say over here in this case, C, B, A, C. And let's take B here also. Something like this we have. Fine. So here we can neglect this b. We can neglect this b because we know that b is present here also. But when we come here, here we cannot neglect this b because this is the last occurrence of b. This is the last index where b is present. So we cannot neglect this b. We have to take it anyway. Even though like a is smaller than this b, but still this is the last occurrence of b, so we have to take it. B, A, C. Fine. So I hope you understood this thing. Let's dry run. Let's see how we can use this thing in our approach. So here, let me erase this. So over here, this test case. Let's take the second test case now. This one. Here we have C and this is D. Fine. So first of all, what I will be doing is I will be taking an array. I'll take a character array. So when I say character array, because these will have characters only, na? And that too also the lowercase English letters. So there will be 26 lowercase English letters. So I'll take an array for storing the last indexes of all characters, of all letters. So this array will be 26 size, 0 to last index will be 25. Okay, this is a character array which I have taken. That is here 0 will be representing A, 1 index will be representing B, 2 index will be C, and 3 index will be D. And similarly this will be E and so on. Okay, so this I have taken. This array I will be storing the last indexes of each letter because that we need to know. So for A, what is the last index? Let me do indexing. 0, 1, 2, 3, 4, 5, 6, 7. What is the last index here? Last index of A, 1, 2, 3. So 2 is the last index of A. Then what is the last index of B? B's last index is 6. C's last index is 7. There are many C's, 0 at 3 index, and then 5 index, and then 7 index. And D is at last 4. So this is your, and rest this will be 0, 0, 0. So not 0, 0, like nothing will be there here. So this is your character array, right? Now what we will be doing is, so see, we let's say we have this CB A, something like this. We are traversing on the string C, B. So see, here we need to check over here. See, when we are at A, we need to see that okay, this B and C letters are bigger than A, right? They are bigger than A. So I can avoid taking these. I can avoid taking these if there are afterwards occurrences of these letters. So I can avoid this CB because C is present after this A also and B is also present after this A. So I can avoid taking these. I can take A, which is the smaller one. So how to store what were the previous characters? What was the previous characters? How we can store that? So we need to have a data structure for that. Previous characters. So for that, we can use a stack. Why stack? Because stack we can use to store the previous characters. Okay, and that too in the order. So this will be first, then this will be, so that like that. Let's take a stack. So I'm taking a stack here to store the previous characters. I'm taking a stack. Also, I've been taking another character array. Let me remove this. I will be taking another character array which will be storing which letter we have taken as of now. So which character we have seen. So this array name I'll writing as seen, and this is also character array 0, 1, 2, 3, 4. Here this is A, B, C, and this is D. Okay, seen. So let's do one thing. Let's dry run step by step. So see what we are doing is we will be we'll start iterating on this string. So first of all we'll go to C. We will see, so there is nothing in the stack as of now, so we will just add the C will be added, and in this here this array will be pre-filled, like we will fill this array before only, before iterating on the string, this last index array. You will understand what is the use of this. Just keep watching. So here first of all we added C in the stack, and then here C, since initially this will be false, everything will be false. Now we have taken this C in the stack, meaning we have considered it, we have considered it. So we will change it to true. So this I will change it to true. Okay, then we will iterate further. So now we will go to B. Now guys, see, very important point here. B letter is there now. Don't you think that rather C being the first letter of the string, B should be the first letter, because B is less than C and it will be more lexicographical smaller string if it starts from B, other rather than starting from C, right? So if this letter is less than the top of the stack, whatever is on the top of the stack, C is on the top of the stack, na? C is on the top of the stack, so B is less than C top of the stack. So B should be in the stack. C can, we can take afterwards only if C. Now another condition, C we can remove only if there is afterwards occurrence of C. So this is what? This is one index, right? Here C is last occurrence. Where is C lastly present? C is present at 7 index. So this last index is greater than the current index, meaning C is also present afterwards. So we can remove this C. We can safely remove this C and we can add this B. And since we have removed the C, so it will change from true to false. Will change from true to false, and yeah, that's it. So what we have done, what step we have done, we have checked the top of the stack. Top of the stack is if the current letter, the current C of I, S of I, let's say S of I, if current letter is less than the top of the stack, here it was B and this was top of the stack was C. If this is less than and C has other occurrences also, so then we can remove this C and we mark in the scene array false. Okay, so this step we have done. Now let's move forward. We go to A. Now again, top of the stack is what? B, and S of I is what? A. A is less than B. So obviously what's better? A string starting from B or a string starting from A? Which one is better? Obviously this is better, right? We have to have the C. We have to have the lexicographical smallest. Here in the problem they are saying smallest. So we will take A. So but before removing this B, we need to check whether B is present afterwards or not. So that we have to take B also, right? We have to have every letter appear once. So we cannot neglect B if it's not present afterwards. But over here, current index is 2 and B's last index is what? 6. So B is present. So we can remove it safely. So from here, I will be removing B, and I forgot to change it to true firstly. So here, true will be there. But now, since B is removed, so it will change to false. Okay. and A we are adding, so A will be changing to true, so it will be true here, and A we will add in the stack. Okay, now let's move forward. So here, now we'll go to C. So here C is the current S of I and top of the stack is A, which is not greater than this C. So this is fine. We can add now. If this is the case, so we can safely add this C in the stack. So this could be the next letter, C. C could be the next letter. Okay, now we go to D. So here S of I is what? D, and top of the stack is what? C. So is C greater than D? No. Fine. So this is fine. We can have D also here. We'll just push. So this is if, otherwise else we just push in the stack. Okay. Now we go here. Now see. Now it will be change. Now it will. Let's see what happens here. Now here S of I is what? C. And top of the stack is what? D. So D is greater than C. D is greater than C, meaning this D should be removed. But do you think this D should remove? This condition is satisfying, but D's last occurrence is what? 4. And current index is what? 5. D's last occurrence was this only. D. This one. There is no more D afterwards. So we cannot remove this D. We'll have to have it. Okay. So even though this condition is getting satisfied, but the last occurrence of D was less than, this is the last occurrence of D. It was less than the current index. This is the current index and this is the last occurrence of D. So then we cannot remove the D. We cannot remove D. Okay. And also we have to change this C's because we have added C na, and D also. So we have to change it to true. I am forgetting it. So we have to change it to true. Then afterwards, now let's move forward. And we will not add this C again. C we will not add again. We will not push because C is already present. C is already not here. C is already present, right? In the stack. So if we will not add C again, then we'll go forward. We'll go to B. So here, what is the current letter B? And it's less than top of the stack, which is D. So we can remove the D, but see D's last occurrence was this only, so we cannot remove it again. So we will just simply push B. Why we will push B now? Because B is not present. It's false. So B we need to push. We will push B. Okay. And then C is here. So C is already present. C is already present. Here true will be there. C is already present, so we will not push it. And string we have iterated C. We have completed this traversal. And here the stack is something like this. So if we push the stack, push items from the stack, so B will be first, then D will be there, then C will be there, and then A will be there. So now we will reverse it. A, C, D, B, and this is the output. A, C, D, B. Okay. I hope you understood this approach. Let's see how, let's see the code now. So see what we have taken. We have taken 3 things. One is the stack. Other one was this last index array. And then this scene array. Okay. So last index array. We are storing the last index of all letters. Then we are taken this scene array and this stack. Okay. Now what we are doing over here, we are iterating. See, this is we are iterating this for loop. We are iterating. If we have seen that character, we will just continue. So here, like for example, C here in this C was already seen. So we just continue. We just move forward. Otherwise, if the top of the stack, see if the top of the stack is greater than S of I, top of the stack is greater than S of I, and I is less than the last index of the top of the stack. So like top of the stack was D, but it's that condition was not satisfying. So we need to check if the last index is when like if there is any other occurrence of that letter or afterwards. So if there is, then we can remove that letter and we can change to false, and we can push the corrector, and we can mark seen as true. So after this for loop, we will have a stack something like this, like this. Then we can just simply pop from the stack, but we popped from the stack, it was in reverse, it was in the reverse order, so we will reverse it and we'll get the output. So we'll reverse it and we get the output and we'll return it. I hope you understood the problem. Time complexity, see, we are doing single traversal. Time complexity is O of n, and space is O of n also, because we are taking this extra data structures. I hope you understood the problem and the approach. Let me know in the comments if you have any doubt. If you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video.